5.2, the mean value theorem practice problems, worked out problems. Whether or not the function satisfies, yada, yada. If it does, find the value. Cool. Well, it's continuous from 0 to 1, and it's differentiable. X to the 2/3. We gotta be careful. At 0 is a cusp, if I'm not mistaken. But if we just go from 0 to 1, we might be okay. I don't know. Let's find out. So find the derivative. Well, let's do it right. 2. Sorry about that. Looks an awful lot like a z. 2/3 x to the 1/3 on the bottom equals, plug in 1, we get out 1. So 1 minus 0 over 1 minus 0. Did not leave a lot of space. Let's go through our little checklist. It is continuous. It is a closed interval. It is differentiable on the interior. So I didn't go over that with the mean value theorem, and I forgot. It's differentiable. Doesn't have to be at the endpoints because it isn't at 0 on interior. So off we go. 2 over 3 x to the 1/3 equals 1. X to the 1/3 equals 2/3. So, yeah. This happens when C equals 8 over 27, because 8 to the 1/3 is 2, and 1 over 27 to 1/3 is 3. And that's in between this interval, so we're good. All right, let's go x minus 1. So this is over 1. That 1 is continuous. It is a closed interval. However, it's not differentiable. So that's a corner. So we're done. Can't do it. All right. Natural log of x minus 1. So here's that. So from there to there, was it 0? Now it's at 1, the asymptote. It looks good. Continuous, closed interval, and differentiable on interior. So we go with the derivative 1 over x minus 1, general, there's nothing, equals ln of 3 minus ln of 1 over 4 minus 2. Ln of 1 is 0, so we're going to do a flippy floppy thing where we get 2 over ln of 3 equals x minus 1. So it will be when c equals 1 plus 2 over ln of 3, also known as 2.820. Click. We graph this one, and we get arc sine, which does something like this. Not on the back post. Back post on the back number at 1. And then 1/2 plus 1 is 3/2. That's at pi over 2 or something. So yeah, it's at a different spot. Actually, I think it's below, if I recall, something like that. And it's a straight line, so not continuous. Prime 5 is using me, right? The equation secant line. Okay, we can do that. Yeah, I'm going to write the points. So the points become 0.5, 1/2. Plug it in, I get 5/2. And the other point is 2. Plug it in, I get 5/2. Looking at a horizontal line of 0 here. So where do we get that? So let's go find the secant line. Equation of the secant line. Okay. M equals 1 minus now let's do the slope is these two lines. 5/2 minus 5/2 over 2 minus 1/2 equals 0. Okay, so slope is 0. You always get 5/2, so secant line y equals 5/2. Then the tangent line f prime of x equals 1 minus 1 over x squared. That has to equal 0. So 1 equals 1 over x squared. Clearly x equals plus or minus 1. 1 is in the interval. -1 is not. So the point is 1 comma 3/2. No. 1 plus 1 over 1. 2. So y equals 2. Slope is 0, it hits 2, y equals 2. Now what a pain. All right, let's do it again. We get 1 comma 0 and 3 comma √2. All right, let's do the secant line. Slope equals √2 minus 0 over 3 minus 1 equals √2 over 2. And I have to stop and think for a minute. Oof, steak. Naughty, naughty, naughty boy. Weird. Okay, so now we go to point slope. I'm going right here, so that's easy. Y equals √2 over 2, x minus 1. That is the secant line. And then the tangent line, f prime of x equals 1 over 2 root x minus 1. That has to equal √2 over 2. 1 over 2 root x minus 1 equals √2 over 2. I get rid of these guys. And then I can say that root x minus 1 equals 1 over √2, also known as √2 over 2. Square both sides, I get x minus 1 equals 1/2, x equals 3/2. So this point becomes 3/2, comma, square root of 1/2, which is √2 over 2, unless I'm very mistaken. Y minus √2 over 2 equals, same slope, √2 over 2, x minus 3/2. Y equals √2/2, x minus 3/2 plus √2/2. Wow, that's a lot of work. Number 7, it took 20 seconds for the temperature to rise from 0 to 12 when the thermometer was taking. At some point, mercury was rising at exactly 10.6 degrees Fahrenheit per second. So let's write it out. F of T is the temperature after T seconds. By the way, I'm overdoing it. You can write this any way you want. Assuming F prime of T is defined and continuous. So basically we're going towards MBT territory here. For 0 less than equal to T is less than equal to 20 seconds. The average rate of change is, right, so this 212 over that 20 is 10.6 degrees Fahrenheit per second. By the mean value theorem, F prime of C equals 10.6 degrees Fahrenheit per second for some C between 0 and 20. Same deal here. Average speed would be 11.9 miles per hour. By the MVT, the runner must have been going that speed at least once when getting up to speed. Since the initial and the final speed are 0 miles per hour, and runner's speed is continuous, by the intermediate value theorem, runner's speed must have been 11 miles per hour at least twice. It's a pain. I prefer more conciseness, but trying to be thorough. All right, use the analytical methods to find the local streamer, blah, 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 blah. Okay. G prime of x equals 2x minus 1. Zero equals 2x minus 1, x equals 1/2. So some sort of graph like that. So there is an absolute min at 1/2. Busting out the calculator because I don't trust my notes. At negative 12.250. So how do I know it's an absolute min? I should have done this first. Sorry. 1/2. Plug in 1 to the derivative, we get a positive number. Plug in 0, we get a negative number. So this is how I knew it was a min. And this also tells me decreasing on negative infinity to 1/2. And again, I always use parentheses, but sometimes they go a different way with it. Increasing on 1/2 to infinity. All right, k prime of x equals negative 2 over x to the third. It never equals 0, but there's a critical point at x equals 0. Probably an asymptote looking at the original equation. So I happen to know the graph looks something like this. So we'll go on either side of 0 just to check it out. We have a negative number. This is positive, negative over negative. We have a positive number. Plug in 1, we get negative. Plug in negative 1, we get positive. So it sure looks like it's decreasing from 0 to infinity. Like say on an increasing infinity is 0. Onwards. This one is never going to hit 0. So we take the derivative, f prime of x, we get negative 0.5 e to the negative 0.5x. Derivative never equals 0. There's no critical points, so let's just plug in any value. Plug in 1. Let's see, 1 over e to the negative 0.5 is a positive number, so that's negative, so it's decreasing. All the time. This one's going to do some little double hump thing. 2y dx equals 4x to the third plus 20x. 4x times x squared minus 5 equals 0. So we get negative root 5, 0, root 5. Number line it. Negative root 5, 0, root 5. Plug in 1. Negative. Plug in negative 1. Positive. Plug in a massively negative number, it's going to be negative. Massively positive number, it's going to be positive. So if we plug in root 5, we're going to get the same thing as if we plug in negative root 5. And that'll end up being 25 minus negative 25 plus 16. I don't trust my brain. I feel like I made a mistake in there. So squared minus 10 times 5 plus 9. Nope. 36. Not what I got. I got 525. Yep, I definitely made a mistake. Can't trust that brain of mine, and then I can't even trust my ability to put in the calculator right. Negative root 16. Holy cow. So it's going to be the same for both of them. So we have a absolute min. Absolute min at negative root 5, comma, negative 16, and root 5, comma, 16. Local. I feel like I've been calling it a different min. Max at 0, comma 9. And then it is decreasing on negative infinity, negative root 5, and 0, comma root 5. And increasing on negative root 5, comma 0, and root 5, comma infinity. All right, so same deal on 13 and 16, 13 through 16. Derivative. Well, before I do that, let's make it easier. X to the 4 thirds plus 8x to the 1 third is 4 over 3x to the 1 third plus 8 thirds x to the 2 thirds on the bottom. I've seen this done so many ways lately. Let's make this times x to the 2 thirds over x to the 2 thirds. 0 equals 4x plus 8 over 3x to the 2 thirds. So x equals negative 2. When we graph this, we get some really funky little weird thing like that. Check it out. Negative 2. Plug in 0. Can't. Plug in 1. Positive. Plug in negative 1. Positive on the bottom. Ooh, I gotta check that out. Yeah, that's right. I still get positive because I'm still on the right side. I'll go ahead. Negative 8. So that's negative 2 squared is 4. Negative. knucklehead. So that would be an absolute min at -2 comma some ugly number, -7.560. Decreasing -infinity to -2. We usually try it on. Increasing on -2 to infinity. X over x squared minus 4, which, if I'm not mistaken, looks something like k prime of x equals low d high minus high d low x squared minus 4 squared equals -x squared minus 4. I think that's correct. X squared minus 4 squared. So where does -x squared minus 4 equal 0? Where does x squared equals -4, which doesn't happen. So yeah, we just look for the asymptotes. So -2 comma 2. We do this fun thing. At 0, bottom's always positive. Top is negative. At 3, bottom's always positive. Top is negative. At -3, so a lot of negative slopes there. So bottom doesn't, the top never, the derivative never equals 0. That's probably a POI. We haven't really discussed that yet. At x equals 0, 0 comma 0, but we won't get into that. So decreasing pretty much everywhere. But technically not at the asymptotes, so we do the whole -infinity, -2 union, -2 to 2, union, 2 comma infinity. I think I've been putting little and signs in here. You can do that too. Whatever works for you. All right. Take a quick glance at what this is going to look like. Something like this. F prime of x equals 3x squared minus 2 plus 2 sine of x. Definitely need a calculator for this one. And it's at -1.126. 1.126 and -0.036. So great place to check is at 0. 0, 0 minus, that's going to be negative out here at 0. Seems wrong, so I got to think about this one. No, it's decreasing. But then phooey. I put in the wrong value. 0.559. That's what happens when you use a calculator. You can get you 0.559. Sorry about that. 0 is definitely negative. Now let's put in pi. It's out here, 3.14. That's going to give me a positive there. It's going to give me 327 minus 621 plus a positive. Definitely going to be going up. And let's go with negative pi. Cosine of negative pi is -1. So that'll be a +1. That'll be negative 27 plus 6. Yeah, it's definitely going to be negative. No, it's not. Yes, it is. I think my graph is wrong. Oh, for goodness sakes, I'm putting it into the wrong function. Life is frustrating. Plug in 0 here, -2, check. Good. Plug in pi, that's also 0, which is a good thing. 3, positive, good. Plug in negative pi, very positive, nothing, good. Ugh. See how easy it is, get lost? All right, so we have a local min at 0.559, -2.369, 639. Local max at -1.126, comma, -0.036. Increasing on negative infinity, -1.126, 0.559 to infinity. Look at all these numbers. Decreasing on -1.126 to 0.559. Q prime of x, 2 minus sine of x. This is a really weird little kind of funky graph over here. Sine of x is never greater than 1, so not possible. So we just plug one value into the derivative, plug in 0, we get a positive number, so it's going to be no critical points. It's going to be increasing always. Find all possible functions with a given derivative. So f of x, no, it's not capital. F of x equals 2x plus some c. F of x equals negative cosine of x plus some c. Wow, I've been looking forward to these problems. F of x equals e to the x plus some c. Ooh, a little tricky. Although I think f of x, it's kind of a giveaway right there. Ln of x minus 1 plus some c, 1 over x minus 1, no chain rule. Now we're going to do the same thing, but we're going to try and solve for c. All right, so f prime of x is that, then let's just guess that it's 1 over x. Derivative, yeah, that works. Plus some c. And the point it goes through is 2, 1. So 1 equals 1/2 plus c. C equals 1/2. f of x equals 1 over x plus 1/2. And they said that x is greater than 0. Oops, what the heck just happened? X is greater than 0. So I have to think a little bit about this. 1 over 4, x to the negative 3/4. Well, I know we add 1, that gives me 1/4, and we divide by 1/4, which cancels this out. So let's see if that's correct. X to the 1/4. Derivative would be 1/4, check. Subtract 1, negative 3/4, check. Plus some c. Negative 2 equals 1 to the 1/4 plus c. That's 1. Subtract c equals negative 3. F of x equals x to the 1/4 minus 3. F of x equals natural log of x plus 2 plus some c. 3 equals natural log of negative 1. Negative 1 plus 2 plus c. 3 equals natural log of 1, which is 0. C equals 3. F of x equals natural log x plus 2 plus 3. F of x equals x squared plus x minus sine of x plus some c. 3 equals 0 plus 0 minus sine of 0 plus c. C equals 3. F of x equals x squared plus x minus sine of x plus 3. Full math. And with what velocity hit the water if you step off 10-meter diving platform? What if you jump up with 2 meters per second? So A of t equals negative 9.8 meters per second squared. I'm going to throw out my units in a second here. V of t equals negative 9.8 t plus my initial velocity. When I jump off, I don't have an initial velocity. S of t equals negative 4.9 t squared plus 10, because I'm 10 meters up. All right, I could have put plus c and figured it all out. Think about it. I'm at 0, 10. No, I'm just at 10. We're just going with 1. I'm at time equals 0 by 10 equals 10. Looks good. So I want to know how long it takes to get to 0. 0 equals negative 4.9 t squared plus 10. 4.9 t squared equals 10. T squared equals 10 over 4.9. Throw out the negative because we're not going back in time. T equals don't trust my brain. Root 10 divided by 4.9. 1.429 seconds. That's how long it takes me. And I bring my units back in. With what velocity hit the water if you step off from a 10-meter diving platform? That didn't answer the question. But it was nice to get to that point. V of 1.429 equals negative 9.8 times 1.429 equals, and I'm just going to use this. I'm going to go negative 9.8 times that. Negative 14, isn't that fascinating? Equals negative 14 meters per second. Cool. All right, what if I jump off? Well, A of t equals negative 9.8 V of t equals negative 9.8 t plus 2. This is negative 14 down. This is 2 up. S of t equals negative 4.9 t squared plus 2t plus 10. 0 equals negative 4.9 t squared plus 2t plus 10. So we got the whole t equals 4.9 oh, that's wrong. Negative 2 plus or minus square root of 4 minus 4 times negative 4.9 times 10 all over negative 9.8. Just want the positive, 1.647 seconds. V of 1.647 seconds equals negative 9.8 times 1.647 plus 2 equals negative 14.142 meters per second. Wow, that's a lot of work. Good luck and happy mathing.